Okay, in this particular question, we have to work at a similar area. So what we do first, we still use the same rule that we use in a similar length. What was that rule? Length of the original time by the scale factor is equal to length of the enlarged. The reason why we need to use the length formula first is because we need to work out what the scale factor is. At the moment, we don't know the scale factor is. We haven't been told the scale factor. So this shouldn't be too difficult. So 3 times by the scale factor is equal to the length enlarged. Okay, now the length enlarged is equal to 6. So the scale factor is nice and straightforward. Is equal to 2. So scale factor is 2. Now, if we're going to work out the area, so we start off with 4 centimeters squared, and that goes to the area enlarged. Okay, so I'm now going to introduce you to this new formula now. The new formula is as follows. Area of original time by the scale factor, wait for it, scale factor squared is equal to the area enlarged. So this is a new rule that I'm introducing you to. So that's what we've been using before. So now the original area was what? What was the original area, Afira? The original area was 4, and then we multiply it by the scale factor. What was the scale factor? 2. So now we're going to do 2 squared. And that will give us the area of the enlarged one. So the enlarged area is not time by 2, is actually time by 2 squared. So what do we get for this calculation? So 4 times by 4 is equal to 16. So the area hasn't doubled in size because the scale factor is double. The area has quadrupled. So now the AE is equal to 16 centimeters squared. And that is the answer. Okay, right. Okay, right. We're looking at this next question here. We have a similar area question where they've given us the area of both shapes. Now we need to work at the scale factor using the area information. And you might ask, why do we do that? And that's the reason why we do that is because the areas correspond. There's no other corresponding information. Because the areas correspond, we have to extract the scale factor from that. Now, when you go from area to area, what we do is the scale factor squared. So we write down here, area of the original time by the scale factor squared is equal to the area of the enlarged. So that's our rule that we can apply. Now, what is the area of the original? 18, which is here. What is the scale factor? That is what we're actually looking for, scale factor squared. And what is the area of the large one? Is 32. Okay. Now, Rutaba, I want to work out the scale factor. Any ideas how we work out the scale factor? Taking into consideration we're starting with the scale factor squared. So what would be the idea for doing it?
You'd rearrange it so you have scale factor squared by itself and you square root all of the answers.
So at the moment the scale factor is first of all being squared and then times by 18. So the last thing being done to the scale factor is being times by 18. So we move the action first, it's solving now. Opposite of time by 18 is divide by 18. So the scale factor squared is equal to 32 divided by 18, which is
1.7 carbon.
So what does that say next to A?
Yeah, 1.7 carbon. AO.
AO. AO stands for area of original.
S dot F.
Okay, what is 1.8 recurring?
1.7 recurring.
Okay, don't use the calculator display because you're going to have to reuse that answer. So don't press on or anything. So our scale factor squared is 1.7. Now we don't want scale factor squared, we want the scale factor. So we take the square over now, and that goes over becomes a square root. So can you square root the previous answer in the calculator, please? Square root the 1.777 recurring. What does that give us?
1.3 recurring.
Okay. So the scale factor by looking at the corresponding areas is given as 1.3. Now we are in the position to work out the length. Remember, we have here length original. Time by the scale factor will give us the length enlarged. Once we worked out the scale factor, which is 1.3, we grab it and we throw it into the formula. So the length original is 6 times by 1.3 recurring will give us the length enlarged, which is x. Now remember, don't delete that 1.3 recurring value from the calculator. Can you times that by 6? What will give you?
8.
Gives you 8 exactly. Stop, is all you got. It's bad, it's confirmation. Yeah, it's confirm report. Okay, so now we're using the formula in reverse. We're working out from area now, and then we're working at scale factor. Okay, are we happy with that? Okay, there's 2 more examples. We'll give you the amount to do with volume. Before we do that, I'm going to give you some questions to do now. So I'm going to stop the video here and give you some questions to do from the sheet I've just given you.